Alright, my name is Derek Wynn, and this is going to be the viscous laminar flow part of my Fluent 3 project. So what I did is just copy the geometry and the meshing from the inviscid flow for laminar and turbulent here. So all I'm going to do is just go into setup, double click here, double precision, force sulfur processes. Okay, for it to load. Ugh. Okay. We'll go into general. Models. Change this from inviscid to laminar. Yep. So now this is viscous laminar, which is what we want. Materials, fluid, air. I'm going to keep the density as 1, but I'm going to change the viscosity to 0.0001. There we go. Okay. And the inlet, I'm going to change the velocity to 10 meters per second from 5. Apply. And this will give a Reynolds number of approximately 100,000, which is below the critical Reynolds number of 500,000 from the calculated. So everything else is still the same. Go to reference values, refresh this. So yep, everything's still 1. Velocity is 10. Viscosity is that. Yep, 0.001. Okay. Look into methods here. Simple, presto, that's what we want. Monitors. Check the residual, it's all the same. Yep, okay. Everything else should be kept the same. Now we can initialize. And I changed the initialization to just 20 iterations. So we'll hit initialize here. That's done. Run the calculations. I got it at 250 iterations. Calculate. Pause it, wait till it's done. Okay, so the calculation's done. I ended up changing the reference values. Ended up changing the velocity to 1.5 and viscosity was 0.01. So calculation's done. Go to an XY plot. Make it pressure coefficient, cylinder. This looks good for viscous laminar. Now if we take a look at the XY plot for velocity, we're gonna see it's just 0. Yep. So that's all done. Okay. We'll take a look at the drag coefficient here. Report, forces, cylinder. Look at the drag coefficient. Prints. 1.03. That's a good number for the drag coefficient, so I'll grab that. Take a look at the velocity contour. Pressure. Compute. Display. Yep. So we got a low wake region there. Close. Do another contour. This time for velocity. Velocity magnitude compute. Yep. So it looks about right for laminar flow. All good. So go head back now. And then go to results. And we'll take a look at the streamlines real quick, and then that'll be it for the laminar. A little bit here. Let's see, tree 2. Open up the streamline. Laminar. Start from velocity inlets. Make this 1000. Apply. Okay, yeah, looks pretty good. Alright, that's all for the viscous laminar. I'm going to be moving on to the viscous turbulent next.